Hello everybody, this is Mr. Krueger and this is Calculus. We're going to go through some problems that might seem a little tricky. So on your review sheet that you're supposed to work on, problems 46, 47, and 48, all dealing with trig. We've got the tangent of theta is equal to 3/2, 3 over 2. The sine of theta is less than 0, and our goal is to find all 6 trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent. So I'm going to walk you through this example problem, and you should be able to do the others based on this. So the first thing I'm going to do is I'm going to draw a triangle. I'm going to ignore this part right here, the fact that the sine of theta is less than 0. I'm going to ignore that part right now. I will get to that part. That will become something that we will need. For now, I'm just going to ignore it. I'm going to focus solely on the tangent of theta is equal to 3 over 2. So sine, cosine, tangent, all that stuff is reliant upon a right triangle, so I'm going to draw a right triangle. It makes no difference how you draw your right triangle. Any orientation will do. And then you got to pick an angle to be theta. You can't pick the 90 degree. That's never going to happen. Any angle you want to be theta, I'll just pick this one down here. That's going to be my theta. So according to the problem, the tangent of theta is equal to 3 over 2. So you have to remember SOHCAHTOA. You have to remember what the tangent represents. The tangent of theta, by definition, is the relationship between the opposite side divided by the adjacent side. And so based on this, the tangent of theta, the ratio of the opposite side to the adjacent side is 3 over 2. So as I can pick anything I want for the opposite side, I can pick anything I want for the adjacent side, as long as the opposite side and the adjacent side are in the ratio of 3 to 2. Well, it would make sense to pick the opposite side as 3 and the adjacent side as 2. Now, it actually doesn't have to be that. You could make the opposite side 6 and the adjacent side 4. You could make the opposite side 15 and the adjacent side 10, as long as they preserve that ratio of 3 over 2. I want to keep my numbers nice and small and easy, so it makes sense to use those numbers there. So we need to figure out the remaining side. We can easily do that. We can use the Pythagorean theorem, the good old PT. So the Pythagorean theorem, in this case, C is the side we're looking for, so we're going to go 3 squared plus 2 squared equals c squared, and then just working that through, 9 plus 4 equals c squared, and so if you power through that, you end up with c equals the square root of 13. If that were to be, if you could simplify that down, say it were like the square root of 8, which reduces down to the square root of 2 over 2, excuse me, the square root of 2, let me fix that, 2 times the square root of 2, you don't need to do that. I don't care. You can leave it like this. You can simplify it if you want. I'm fine with that. So I'm going to get rid of this work here for the Pythagorean theorem. Now that we've got all 3 sides, we can now figure out all 6 trigonometric functions for theta. That's our goal. So we just have to know the ratios. So the sine of theta, according to our definition, the sine of theta is defined as the opposite side divided by the hypotenuse. So with the setup that I have, the opposite side of theta is 3. The hypotenuse is the square root of 13. I do not need that rationalized. It would be 3 square root 13 over 13. If you wanted to rationalize it, feel free to. I'm fine with this as an answer. But I want exact answers. I don't want decimals. Don't punch that up on a calculator and give me whatever decimal equivalent it is. That's not good enough. This is the exact answer. This is what we want. For the cosine of theta, the cosine of theta will be the adjacent side over the hypotenuse, so that will be 2 over the square root of 13. The tangent of theta we already have. It is 3 over 2, so I don't need to rewrite that. You could if you wanted to, but there is no need. And then we have the other 3 trigonometric functions. We have the cosecant of theta. Once you get these 3, the rest of these are easy. If you recall, the cosecant is really just 1 over the sine of theta. So basically take the sine of theta and flip it. It's the reciprocal of that fraction, so that's going to be radical 13 over 3. The secant of theta is going to be 1 over the cosine, so that's going to be radical 13 over 2. And then finally the cotangent of theta, if I can squeeze it in there, will be the reciprocal of the tangent, so that's going to be 2/3. Now, if we lived in a world of all positives, if we lived in a world where everything was only in the first quadrant, we'd be done. But we don't. All of these numerical values are fine. It's just, are they positive or are they negative? That's what we have to worry about. And so that's where this piece of information, the fact that the sine of theta is less than 0, that's going to come into play. So I'm going to get rid of this triangle just so I have some space so I can do the rest of the work here. So now that we have all those trigonometric functions, the triangle is no longer needed. We need to look at the quadrants. And so I'm just going to draw up the x and the y-axis. We have our 4 quadrants: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If you recall from your pre-calculus days, we have the phrase, all students take calculus. This is strictly reliant, focusing on the sine, the cosine, and the tangent only, ignoring the bottom 3 down there. We have all, which means all 3, tangent, sine, cosine, as well as the other 3 down there, but again, we're ignoring those. All of them are positive in the first quadrant. All students, in the second quadrant, sine is the only thing that's positive. Take, in the third quadrant, tangent's the only thing that's positive. Calculus, in the fourth quadrant, cosine's the only thing that's positive. Now that's only focusing on these 3, not looking at the cosecant, secant, and cotangent. But if we can get the positives and negatives of sine, cosine, and tangent, we get the other 3 for free. So we need to figure out what quadrant we are in. Well, first it says tangent is positive, right? It says the tangent of theta is 3/2. So we have to look and see where is tangent positive. Well, tangent is positive in the first quadrant, and tangent is positive in the third quadrant. So those are the only 2 places that I could possibly be based on this information. However, we also have some other information. We have the fact that the cosine, excuse me, not the cosine, we have the sine is less than 0. So with that information, I look at these 4 quadrants, and I have to look at when is the sine less than 0. Well, everything's positive in the first quadrant, sine is positive in the second quadrant, so that means sine is negative in the third and fourth quadrant. So where do we have overlap? Which section is highlighted in both purple and green-ish? That would be quadrant 3. So quadrant 3 is where my triangle actually lives. And in quadrant 3, tangent's the only thing that's positive. So the tangent of theta equals positive 3/2. We know that. If you flip a positive fraction 3/2, the cotangent is also going to be positive. So that one's okay. The others, in that fourth quadrant, sine is negative. And so I'm going to just give that a negative sign. Negative 3 over radical 13. Cosine is also negative in that quadrant, so I'm going to give it a negative sign, negative 2 over radical 13. If I take those 2 fractions and flip them, the reciprocal of the sine of theta is the cosecant of theta. Well, if you flip a negative fraction, it stays negative, so the cosecant, also negative. If you take the cosine and flip it, same rationale, same argument, that's also going to be negative. And now I have all 6 trigonometric functions correct with positives and negatives. This is how you want to go about figuring out the answers to these problems.